I'm Roger Lipscombe, and I work in the back-end team at Electric Imp, where we provide a platform as a service to allow manufacturers and hobbyists to connect things to the internet. About a year ago, we migrated a large part of our back-end systems from node.js to Erlang. We're a couple of weeks, maybe a month, I'm a developer after all, from completing the migration of another large chunk of that. I want to talk to you about what the Internet of Things is, what that means to us at Electric Imp, what our platform looks like to our users. I'll talk about why we decided to migrate our backend to Erlang, some of the problems that we faced during that migration, and why, in the end, we think that it's the right choice. I need to point out that while I'm here, in an official capacity, hence the t-shirt, I do spend all my time at the coalface, so anything I say in this presentation should be taken with a grain of salt and should not be used to base investment decisions on, and so on and so forth. So, what is the Internet of Things, or IoT? Simply, it's connecting things to the Internet. What kind of things? Everything. Talking about vehicles, appliances, buildings, animals, plants, even soil. Everything. In fact, Cisco and Intel, among others, have started referring to it as the Internet of Everything, probably as a differentiator so they can make more money off of it, but hey ho. The Internet of Things has probably generated more hype recently than most other things, and I feel duty bound to point out that there have been a lot of stupid things connected to the Internet, such as a toilet that you can flush using your smartphone, an egg tray which tells you how many eggs you have left, and a fork that checks you're chewing your food properly. But it's on the Internet, so that's cool. I should confess that we are responsible, or at least one of our customers is, for one of those. You can check our website to find out which one. But what might seem frivolous to one person might be essential to another. And there are a lot of potential efficiencies and savings to be found by connecting things to the Internet. For example, how about a clothes dryer that negotiates with your electricity supplier for the lowest rates and runs when power is cheap? That's going to come in quite useful when we turned off the last nuclear reactor and we're all running on wind power, which is unpredictable. Similarly, and this is one of our customer products, what about a sprinkler system? It checks the weather and it doesn't bother watering your lawn if it's going to rain anyway. I was going to bring it with me, but it turns out it's quite large, so I didn't bother. I read about another good example yesterday while I was preparing this talk, dustbins. Traditionally, you send the bin men around once a week, but on any given round, particularly for public dustbins, the bins are empty, some of them are overflowing. So what if, by connecting your bin to the Internet, you can monitor the level of waste in that bin and just send the guys around when they're needed? Brilliant. Similarly, there are efficiency savings to be found in other areas, such as buildings management, which is a vertical we're trying to get into. You can optimise your lift maintenance schedules, your air conditioning and heating inspections. You can make sure the engineer has the right stuff with him when he turns up. It saves a lot of money. So there's a massive potential upside to the Internet of Things. But, this is part of where we come in, how do you get your thing connected to the Internet? It turns out that it's actually a remarkably difficult problem. You're thinking, no it's not, Wi-Fi, done. But even if you restrict yourself to connecting via Wi-Fi, there's a whole heap of problems to deal with. For a start, how do you feed the Wi-Fi credentials to the device? Chromecast, I don't know who's got a Chromecast, deals with that particularly slick way. It basically sets up an ad hoc network with your phone and uses that to feed the real credentials over to the device. Brilliant. The way we do it is we've got a thing called Blink Up, which flashes your phone screen and transmits the details to an opto sensor on the device. That's pretty cool too. So great, I've got the credentials on my device, it can connect to the Wi-Fi. The next problem you've got is standards. Not every device interprets the standards in the same way. There are hundreds of different Wi-Fi access points out there, all running different software stacks, all got their own bugs, missed features, idiosyncrasies, incompatibilities. We've got like a stack of about 20 of them in our Cambridge office, just sitting there for compatibility testing. And the story just gets worse if you want to use cellular, because now you've got to pay a chunk of money to the phone companies. Okay, so let's assume you've dealt with that, and you've got your device connected. How do you keep the software up to date? How do you keep the OS up to date? I'm not going to touch too much on security because that's what my CEO does in the fish field, so I'm going to try and save some of that. But if you're making sprinkler devices or air conditioning units, one of our customers does that, something you probably don't have the resources, the time, the inclination, or the expertise to tackle. You just want it to work. So as a manufacturer, you're probably thinking, this ought to be a solved problem. Why doesn't somebody else solve it for me? Which is where we come in, Electric Imp. So at this point, because it's relevant to why we're using Erlang, I need to give you a little bit of background about what the Electric Imp platform looks like to someone using it. Try not to be a bit of a sales spiel, but it's going to sound a bit like that anyway. So, I did bring some stuff. You take one of our modules, the Imp, which is here on a development board. That's the Imp there. You make a smaller one now. Yeah, I think it's plastic already, but try not to drop it. And you build that into your device. Now, I do have to let you down slightly because everybody's going, oh, it's Erlang, fantastic. That doesn't run Erlang. I think as it stands, the smallest Erlang you can get is about 20 meg. That's got 128k on it. It ain't going to fit. So instead what we do is that hosts a Squirrel virtual machine. I don't know if anybody's heard of Squirrel, but it's kind of like Lua, but with OO, but designed to be embedded. And the reason we do that is it makes it easy to program for starters, but it also allows us to isolate the OS parts, which deal with all the security and upgrades and the rest of it, from the application parts, which our customers write, or the hobbyists we have on our platform. So that's pretty cool. Then you use Link Up on your phone to connect your Imp to your Wi-Fi to the internet. It uses this connection to talk to an agent. It's kind of like a Pico VM, also running Squirrel, which is hosted in our cloud service. Picture of a cloud. One design decision we made way back when is that the Imp itself cannot talk to anything other than its agent. The agent takes care of everything. So the Imp has no local network access, it has no internal or inbound or outbound HTTP. The agent takes care of all that on the Imp's behalf. We did this to keep the attack surface on the Imp as small as possible. There's just one connection. It's TLS. It's signed on both ends, client and server certificates. It's hopefully pretty secure. So if your agent does need to talk to an external service, it can talk HTTP. If your mobile app needs to talk to the device, it can talk to the agent using HTTP, and then that talks to the device. Agents can talk to each other using HTTP, or like that. We have a stack of agent integrations to third parties, such as Zyvy for collecting data samples, popping up for event bus type things, and a whole bunch more. And it turns out that for a lot of applications, this is perfect. You can take advantage of the permanently running agent up here in the cloud, and that can just do all kinds of comms. The size of that's bigger. You can get that to do a bunch of work, and you can simply wake up and check in every now and then to either upload some new data samples or just to see if there's any work to be done. So, where that's important is because we're trying to aim for partly the not always connected market. So, this not always connected behaviour is great for battery life. I think on our website we've got a quote somewhere that says that when the Imp is in deep sleep, so it's got pretty much everything turned off, it will run for over 2 years on 2 AA batteries. Obviously when it wakes up to take samples and when it wakes up to connect to the internet to upload those samples, that hits the battery life. Pretty impressive. So, that's our platform. And I think because of the fact that our devices are talking to our servers rather than doing their own comms, because of that, I'm off track. Let's try again. So, why did we look at Erlang? So, to recap, we've got a bunch of always connected devices, such as the water sprinkler I mentioned earlier, and we've got a bunch of intermittently connected devices. And they're connected to our servers rather than directly to each other. And they need to talk to their agents, and their agents need to respond to HTTP, etc., etc. And this quote from Erlang.org gives us a flavour of why we initially started to evaluate Erlang as a solution for re-implementing our back-end system, which used to be node.js. So the quote is, I'm sure you've seen it, it says, Erlang is a programming language used to build massively scalable, soft real-time systems with requirements on high availability. Erlang's runtime system has built-in support for concurrency, distribution, and fault tolerance. Fantastic. It can be used to build massively scalable systems. Cisco, amongst other people, including Gartner, are talking about 25 billion devices connected to the internet by the end of this year. They reckon 50 billion by the end of 2020. If even a small percentage of those devices are on our system, it had better be massively scalable. And also I can buy a Ferrari. Software real time. That's not such a big deal for the Internet of Things because the internet gets in the way. But responsiveness and fairly good latency is important for quite a lot of our customers, so that's important too. High availability, you don't want it to go wrong. I think we're nowhere near 9.9s at this point, but it's a good goal to aim for. Getting back to the original reason we looked at it, concurrency. We're dealing with hundreds of thousands of connected and intermittently connected devices at any one time. So support for concurrency, because they're all doing their own thing, seems like a good thing to have. Distribution of fault tolerance, they sound good too. Having a self-healing system is way better than being woken up at 3 in the morning because of an issue in production, plus minus. So, shortly after I joined Electric Imp, I was given the task of putting together a prototype to see if it would work. It seemed to work. So we started rebuilding our back end, or at least the most important parts, using Erlang. Fantastic. So, what does our back-end architecture look like? And where do we use Erlang? I'm showing this slide because I think a lot of people have got questions about how Erlang fits into a larger system. And so, in our back-end, not that any of this is rocket science, we use a lot of third-party software, some of which, shock horror, isn't written in Erlang, we have to integrate that. So I thought this slide might be useful to show how Erlang fits into that larger system. So we have a bunch of imps, significantly more than 4, by the way, out here which connect to the imp server. That accepts a connection, figures out if they need a software upgrade, both OS and application level stuff. It might send them to a different software for load balancing purposes, sorry, to a different server for load balancing purposes. And then otherwise it just basically sits and mediates the comms between the agent and the device, and vice versa. So the agents are hosted in the agent server. And those two are running as a pair on the same box, of which we have several. Now, the agent server is the other piece of the migration to Erlang that I was talking about earlier. We've had Imp server running on Erlang for just over a year now, I think. But this bit is still, as of today, running on node.js. And I'm kind of hoping that in the next couple of weeks we'll get that onto staging in an Erlang implementation. It's sitting in a branch just off master. With about 6 commits to go. So that's something we hope to do soon. Now this agent server over here, that hosts the Squirrel virtual machine for each agent, I mentioned that earlier. So each device talks to a single agent, that channel, and then the agent can do HTTP or whatever to where it needs to do. That Squirrel runtime is implemented in C++, and we interface it to Erlang using NIFs, native implemented functions, which is a way to load native code into an Erlang node. We looked at other options. We looked at port drivers, we looked at ports, we looked at C nodes, and we decided NIFs was probably the quickest and easiest, and probably the most performant way to do it. And we run tens of thousands of those, not these, but VMs, Squirrel VMs per server. The two daemons are currently separate, two nodes currently separate. That's partly for historical reasons, because part is written in node.js at the moment, and partly because at some point we might think about distributing the agents to do some load balancing, failover and reliability things. Excuse me. So, but at the moment they run on the same box because it keeps the latency low, which is nice. As I mentioned, so these bits are, or soon will be, in Erlang. Pretty much all the rest of it isn't. As I mentioned, the agent can talk HTTP to the cloud, to external HTTP services, and it can serve HTTP itself. We use Nginx for that, with a little bit of Lua for inbound HTTP routing. So HTTP comes into Nginx behind the load balancer. That then looks up in the registry where the actual agent for that request is running, and then sends it to agent server, which uses Cowboy, if you've heard of Cowboy, to actually get that into the Squirrel VM. We use Postgres for our relational data. We use Redis as a key value store. We've got RabbitMQ in there, that is written in Erlang, for administration messages and events. And they're all configured for, that one, they're all configured for clustering or master-slave failover for HA purposes. For example, our slave Postgres is in a completely different, we're on Amazon by the way, our slave Postgres is in a completely different region. We have a web-based development environment and customer ops console, which talks to API, and that bit is still implemented in node.js, though we might migrate to Erlang later this year at some point. I say might, because it currently works fine. Node.js is ideal for building websites and stuff, so the only real benefit for utilising it in Erlang is the fact that we can share more code between the different bits, which is, it's a worthwhile benefit, but it's just not worth worrying about right now. For monitoring, we use Nagios, I think it's pronounced actually, and Graphite and Grafana. And for logging, we're currently just using syslog, but we are evaluating Logstash and Kibana for indexing and querying and stuff, because Splunk is too damn expensive. So, why might you not choose Erlang? There's a really good talk on YouTube by Garrett Smith called Why the Cool Kids Don't Use Erlang, in which he presents the results of an informal survey he did into people's thoughts about Erlang, mostly on the Erlang users mailing list. It turns out the respondents mostly love Erlang. He presented this as a big word cloud, and like love was the biggest word in the set. And we do mean love. There's a great quote from last year's Code Mesh where Bet365, who've moved their systems to Erlang, or a chunk of it, so they talked about that, and they said, the quote goes, smell this, the speed that developers go from hating Erlang to falling in love with it is very, very surprising. Of course, that could just mean that Stockholm Syndrome is strong with this one, but... Or Garrett's results could just mean that a survey on the Erlang users mailing list is a little bit self-selecting. I do have to admit that choosing Erlang was a risk for us. It's niche. There aren't a lot of developers out there. I mean, who is actually developing in Erlang versus just toying with it? I know Roger is. You are, Jeff. Yeah, but you know, again, it's a self-selecting group. So when we started the migration, the only experience we had in the team was I'd done a 3-day training course in this room, and I had to train the rest of the team. So that was, you know, challenging. But there are also a bunch of other things which form a barrier to entry, barrier to using Erlang, and that could and should be improved. The one I have to get out of the way first is the syntax. Everybody says the syntax is weird. And I've got to point out that they're wrong. No, it is weird. The thing is, to a C programmer, VB syntax is weird. To a Python programmer, C syntax is weird. It's not weird, you just got to get used to it. Or it could be Stockholm Syndrome kicking in again, I don't know. If you fancy something a bit more Ruby-like, look at Elixir. The other one which it turns out, came out, and my personal experience is the same, is that there's a little bit of a learning curve when it comes to bringing up your first Erlang application. You can fire up shell, you can type things into it, that's great. Once you get over the, you know, the lists and the prop lists and the atoms and the values and the fact that you can't single assignment, and that throws people all the time. But bringing up your first application is a bit of a hurdle. For example, when we were in our US office in January for our all hands this year, I did an Erlang training course with the embedded and hardware engineers, just, you know, so they understood what we were talking about. And it turns out to fire up a simple Hello World web application, this is after I'd got them over the different types, the lists and the atoms and the things, and got them through the shell, and got them past the single assignment. It takes about half an hour, the introduction to Erlang, the Erlang way of doing things. A module for this, and a supervisor for that, and a config file over here. And
that's OTP, it's not Erlang.
Yeah.
So you don't have to use OTP.
I know.
Hello World is about overkill.
For printing Hello World to the console, great, yeah, that's easy. You want to do a web app,
yeah.
You've either got to use Cowboy, or Mochi, or the built-in one, which is rubbish. And there's a bunch of boilerplate, it's annoying. And you've got to understand a bunch of it before you just, it's just incantation of, I don't know what that is yet, and it's a bit scary to people. Which is fine, it's a bunch of boilerplate, but when you can consider you can do the same thing with 5 or 6 lines of Node, and in fact their website has 6 lines of Node, this is a web server, great, fantastic, it turns people off a bit, it's a bit of a hurdle. So that's a challenge that we
I'd argue you could do a similar web server in Erlang, just not in OTP, in a similar number of lines, which would be the equivalent of the node.js version. So it's unfair to compare node.js with an OTP app.
That's an interesting point. I mean, what would you use for the actual HTTP library, the built-in stuff?
Yeah, it's built in, there's stuff built into it. Like, so I write a standalone HTTP server in a few lines.
If I had a glove, I'd lay it down in front of you. But, you know, there is a bunch of...
You don't. You use OTP because you want it to be reliable and restart.
Exactly. But the thing is, you've got to build...
But the Node.js one doesn't do that.
No, Node.js explicitly doesn't do that. It's slow about that there. But the thing is, you know, if we're introducing Erlang to people in terms of, we go, okay, even if we went, this is really easy, then suddenly there's another cliff, or it's like suddenly you've got to learn OTP. Oh my God, what's this all about? The tooling, in particular, is an 80s retro throwback. The de facto build tool Rebar sucks quite hard. There are a couple of alternatives, including the new version of Rebar, which looks quite good, but there's no real strong consensus out there right now. A couple of notefile-based ones. Yeah. Package management consists mostly of using Google and then clicking on the first GitHub link that you find. That's how we do it. Some packages are really good, some less so. Some are actively maintained. Some haven't been touched in years. It's kind of hard to tell. That's not actually a package management problem, although Erlang has that problem. It's a package curation problem. But despite a bunch of discussions in the Erlang mailing list, that's not going anywhere either. Because either people go, it's not a problem, just use GitHub, or they overthink it and start trying to suggest crazy ways. It's different. The Erlang way of doing things is different from the Unix way of doing things, or from the Windows way of doing things. And that's usually for sensible reasons, because you want to do zero downtime upgrades, you want to do releasing in a particular way, you've got your config files configured in a particular way. And it all makes perfect sense once you've grokked OTP. But it's another hurdle, particularly from a DevOps point of view. My deployment process is completely different from anything I'm used to. I want to install this thing using Chef. Well, you can't. Tough. Maybe you can, actually. I don't know. We don't. The documentation is patching, or at least that's been an accusation leveled against it in Garrett's survey. Some of the documentation is very, very good. Some of it's mediocre, and some of it is downright terrible. Personally, I'm mostly okay with it. I much prefer to the Python documentation, for example, but some people struggle with it. One good thing, but also one bad thing. Testing in Erlang, it's first-class citizen. It's got stuff built in for testing. It's great. It's got eUnit for unit testing. It's got common test for integration and system testing. But common test, in particular, is a bit baroque. Poorly documented, hard to understand, and in places it's just plain weird. The libraries are inconsistent. If the module for handling lists, you know, and it's called lists, why is the module for handling queues not called queues? It's called queue. There's no real agreement about whether the most important parameter goes first or last in the function call. It's more annoying. And I regularly have to dip back into the patchy documentation to double check whether I've got it right or not. Talking about libraries, the library functionality included in OTP is a little bit eclectic. There's no JSON library, but there is an H248 library, which makes perfect sense when you consider it's got a telecoms background, but it's a bit weird if you come into it with a modern set of eyes. So, all these negative things. But my point is, it's actually totally worth it. Get over it. Just use Erlang, frankly. So why would I choose Erlang? I choose Erlang because it is the original hipster language. It's cool, like in a retro style. It's functional, it's actor-based, it's concurrent, and all the functional actor-based concurrent languages and frameworks are just about starting to hit the mainstream. You've got Scala, you've got F#, you've got Go. If you look at actor stuff, you've got Akka. I was talking to Roger earlier about Project Alliance, which is Microsoft's actor thing they've been using for Halo. Erlang has had all those features since way before they were cool. It's a hipster language, it's great. It's solid, it's mature. It's a retro throwback again. The community, is small, which has its upsides and downsides, but on the mailing list and the IRC channel is filled with very, very smart people who are willing to share their time and expertise with you. even if you're a complete noob. Sometimes they can be a little bit scathing, but that's mainly because you're stupid. And if, by talking about Erlang, I mean Erlang LLC, including all the libraries, it's got a whole heap of features which are fantastic that allow you to inspect, diagnose, debug, fix, and patch your running system in production without even knowing it. Fantastic. I had a thing a couple of weeks back. My project manager was, oh, we're going to need to bounce the server to do that. No, but we didn't know. I've done it. Nobody noticed. It's done. It's hot patched. It's all sorted. Fantastic. Great. The inspection utilities are fantastic. I can just, rather than on my node.js box, if it goes a little bit wrong, I have no idea. Hands up. I can get in the remote shell on the Erlang node, start asking questions. What processes are stuck in where? How many things are connected? What do they think they're doing? Oh, okay, and then I can just fix it. I mean, obviously, we go back and patch the source code as well, but you know, mostly. So it's so good, in fact, that in a moment of epiphany a while back, I'd sort of commented to my colleagues, it's almost like they designed something that was actually intended to be used in production. Which is super. So I think that after the runtime inspection, the ability to inspect a running system and patch it and ask it questions, my next most favourite feature is the fault tolerance. It turns out that let it crash normally really is the right way to build an Erlang system. You write the happy path, and you just let your supervision tree deal with it. This crashes, meh, gets restarted. This crashes, meh, gets restarted. So, for us at least, Erlang is absolutely the right solution to our particular problem. And it does mean, it's a good thing, that I no longer get woken up at 3 in the morning with a production issue, which is superb. I get to sleep. There we go. Questions? About 5 or 10 minutes. If anyone's got any more depth, I'll be across the road.
Can you go back to your diagram with the architecture?
Yes.
So,
Hang on.
it'd be interesting some of the decision points behind some of those.
Yeah, I can go to that. I mean, some of this is historical. But
Did you look at Yums at all as a web server? What was the thinking behind going NGINX rather than Yums? Rather than yours, I should say.
So the deal is that this Nginx, there's 3 of those sitting on a load balancer, but there are way more than 3 of these, and the load balance, the affinity isn't quite 1-to-1. So what we do is we take a look at the inbound URL, figure out which agent that's destined for, and route it to the right place. Now we could have done that in Erlang and spun up an entirely new Erlang node over here, but the same Nginx cluster actually routes all this stuff over here as well. So with a little bit of Lua and a lookup in Redis, job's good.
If the agent server itself is written in Erlang, then you can actually have the web service in yours, and then call that directly from within yours. That's the benefit of yours, that it integrate, because it's part of the Erlang ecosystem. You can make calls into the rest of your Erlang world.
Well, that's pretty much what we've got going on anyway. The Nginx talks to the cowboy here. So.
So you had to use Nginx and cowboy to
I mean.
Whereas if you use yours, you've got the native Erlang messaging.
Oh, I see what you mean. So if we'd had yours or Moxie or cowboy here, we could have put that in a.
In yours, you embed Erlang code into it, and you can call Erlang modules directly.
Yeah, but we'd still have had to go to another box where the agent's actually running. So.
Yeah, but it doesn't matter. It's in the Erlang ecosystem.
Yeah, it's a trade-off. We could have done that, but as I say, at the moment this is actually written in Node.js anyway. That's right. That's right. So you didn't have the option anyway. We might revisit that later.
I welcomed your concern earlier about standards, which you highlighted. But then I noticed you're a Mac user, and of course, as we all know, Apple consistently trashes standards and then tries to build parallel ones of their own.
What my other options, Microsoft?
GNU Linux, maybe?
At home, I do run Linux. Our back end is a Linux.
People think it's just a tool to...
No. Our back end is Ubuntu on AWS, EC2. My desktop at home is Linux Mint box. The Mac I use because it's to make nice laptops, and I haven't bothered installing
Just
Linux.
works, you're going to tell me, except when it doesn't.
It normally just works. It did crash on me this afternoon when I was trying to put slides together, which was slightly disturbing. But yeah, I mean, it's a very shiny aluminium Unix box. That's all I care about.
Do you know Cory Doctorow?
I've heard the name. I've never actually met him.
He used to be a Mac fan, but you should read some of his posts.
The one thing you have to bear in mind is that some of our management team came from Apple, so there's a certain amount of shiny by that. I use an Android phone and they hate me for it.
So obviously, Internet of Things, 50 billion devices. You're talking about tens of thousands on a server. That kind of starts to look like an awful lot of servers to me.
That's as it stands right now. We could probably pack more density than that.
What do you think is the limit there? What are the limiting factors?
Top of my head, I don't know. I'll have to dig into that for you.
Are you actively doing anything in the scalable Erlang area?
No, we in our system haven't reached any particular limits of Erlang scalability. Because a lot of the scalability we actually handed off to the imps.
So OTP out of the box, 40 servers is about what you'll get. If you start to do...
You're assuming we want them in a cluster?
Yeah.
We don't.
Yeah.
If
you start to do hidden nodes and those kind of things, then probably 400.
Yeah, we don't currently have them clustered.
Yeah.
The imp does the load balancing. The imp turns up at one server, we say, hey, you should be over there. He disconnects and reconnects over there. Which means the only thing that's in a cluster is the imp and agent server on that one box.
Yeah.
We then have an admin console, which is a hidden node, talking to all the rest of them.
Yeah.
So there's no actual 40 node cluster. I'm sure at some point we might get to that. We'd like to get to that.
Well, that's right. Once you've got your agent migrated onto Erlang, then you can pull that together.
But even then, we might just decide to have smaller clusters.
Yeah. Well, the way
we might put 40 servers in a particular AZ, and then put another 40 servers in.
So have a look at. There's a fork of OTP done for the release project, which was the Scalable Erlang project under the EU funding. So
yes, I think
so Glasgow University did most of that. So have a look at that fork. They were something called S groups, which allow
yes, I think I saw a presentation.
You to partition
that.
A cluster into smaller groups, and that they benchmark that and go up to 400 nodes.
Yeah, and that's going to be interesting stuff for us, particularly when we start doing more regional stuff. Because we definitely don't want those in a cluster, because as soon as you start going across a WAN, it's going to kill you.
I'm working with some of those guys and other interested parties in trying to take it to the next level. So we're trying to take Erlang beyond the 400. Certainly, there's interest in doing that.
That's interesting. I'd like to talk to you a bit more about it.
So yes, we can talk on that. So we try to get interested bodies together in that area. The problem's been that Ericsson isn't motivated to do that. For them, 40 nodes is fine.
Yeah, I mean, the thing that comes me is the guys at Erlang Solutions have got their Wombat solution, and they're trying to scale into thousands of nodes, and I'm not sure how that works versus your 40.
Yeah. So they actually did some work with Glasgow University on that. So they were part of that work.
Okay. Well,
again,
that sounds interesting.
They were a collaborator in that release program. So
this is a big field, and I understand that you've you used Node.js for a lot of it beforehand, and was wondering if you explored like the fault tolerant options in Node.js before you decided to move on to Erlang. Like, what were the key things that made you move to Erlang? Because a lot of people on the internet would say there's a fair amount of overlap in what APIs do.
I think there's a bunch of different reasons. The Node.js stuff that we had at the time, the fundamental problem that I have with Node.js is that it's single-threaded and uses continuation parsing style concurrency, which is basically it sucks.
There's a lot of options like you've got in order to work around that. I mean, for example, you could spend
you've got to work around it. It's like, I could do promises, I could do generators in ES6, but
you have multiple processes as well, and like
but those processes are real processes, whereas my Erlang processes are basically free.
That's true.
Yeah, I mean, you're right. At the time we were looking at doing this move, we were talking about Node 0.7-ish, so a lot of this stuff wasn't very mature. The promises library, I think the biggest misstep Node has made is gone, we're not going to bless a promise library. And now I've got a whole bunch of libraries that use one promise library and a whole bunch of libraries that use a different one. They've all got to talk the normal continuation path, and it's just insane. So I'm kind of hoping that somebody fixes that, but at the the time, this looked like the right answer, and it's made me sleep well at night, so I'm happy with that.
So I came a bit late, so I don't know if you have talked about that. How have you managed the deployment process while you were migrating from Node.js to Erlang?
Okay, so I didn't actually talk about the deployment process. The way we do our deployment process is a little bit old school. It's the way we basically did it with Node anyway. We haven't taken advantage of any of the rel-ups or app-up stuff in Erlang. We don't use the Erlang zero downtime stuff except for hot patches. What we do is we spin up an entire new server farm, and then we kick everybody off the old one, and then we kill that one. And then we do that every couple of weeks, just flip-flop. That works pretty well with Erlang anyway, because as I said, we've got that admin console that connects to the clusters, so it just goes from you, move over there, everybody's happy. One of the things on my list for this year is to properly look at doing Erlang releases, so we do proper in-place upgrades with zero downtime, zero movement. But at the time, Francesco hadn't finished that chapter in his book, so.
So anything, I mean, any other times is because I know like in Node.js you would store many servers in one box, or in Erlang you would like want to be able to control minimal resources than the Node.js instance would do. I mean,
Sorry, I didn't catch that.
I mean, in Node.js world, you would, I'm assuming you would have much smaller boxes to handle your.
I see. You're saying we'd have more smaller boxes to handle the same load.
Yeah, I mean, how have you managed to migrate from that?
Well, the thing is that when we do the whole A to B or B to A migration, we can have different sizes in the sets. So we went from n node boxes and squished that down to fewer Erlang boxes, and to optimise that, we're down to even fewer. So it turns out not to have been particularly a problem. We are on fewer Erlang boxes than we were node boxes. They're handling more load. They're more reliable for stampedes. So one of the particular things about the imp is if you kill its network connection, it comes straight back at you. Which means if the daemon falls over, which it used to on the node fairly often, but it doesn't that much on the Erlang, suddenly, wham, you've got tens of thousands of devices going, hey! And you're like, oh, so previously for Node.js, single-threaded, we had way more boxes to deal with that initial inrush. For Erlang, it just goes a bit slower, but it doesn't die. So that's been a real help for us from a cost-saving point of view and a DevOps point of view.
So, quick question about monitoring. You said you have integrations with Nagios and Graphite and stuff. Are you using something like Folsom or Exometer?
Yes, that's a good question.
And kind of what's your experience with it? Because I would like to.
So our monitoring and logging, actually in the Erlang pieces, we use Lager for our logging. We use a syslog backend, which gets it all into syslog or Logstash. We've got a Rabbit backend, which just sends errors that we get emailed. So we can triage them every morning, work out if anything actually needs fixing. If it's, it died, never mind. For the stats, we use Folsom, exactly, to win Folsomite. We had a quick look at Exometer.
Well, it's my sometimes.
Is it yours?
That was.
And that looked pretty cool, but we'd already plunked on Folsom at the time, so no, it's Alt, isn't it? So we might look at Folsom again. At Exometer at some point, but Folsom does the job for us quite well.
I'm just interested because I'm facing the same kind of need, so it's kind of getting your input between the.
We've been really happy with Folsom. The only problem I have had with it is that it comes up with a particularly weird way of naming the metrics. So we've got a fork in our repo that allows you a bit more flexibility on those, which makes it then easier to set up template dashboards in Grafana to actually filter down to a particular server.
Have you got any vanity metrics with you at all with number of connected devices, number of agents, sensor resolution, amount of data stored, anything like that?
No vanity metrics. That's all classified. I could tell you, but I'd have to kill you. It's buy me drinks. The only numbers I have got is we've got tens of thousands of agents on a particular server. we've sold 500,000 devices. They're not all connected all the time, but
Can you tell us something about the applications? What devices are out there that you're using?
so some of them are resolutely in the Internet of Stupid Things category. The egg tray is in fact ours. Most of it is, at the moment is hobbyist stuff. We've got some cool stuff coming down the pipe. So one of the cool new things right now is an aircon unit. So that's home aircon. We've got some really cool stuff which I can't tell you about because while the customers announced it, they've not announced that our stuff's in it, and so I can't tell you about it. So unfortunately, give it a week.
Yeah, because I think we've got the Hive stuff, home automation, like a massive scale.
Mm-hmm.
I'm sure it needs some sort of infrastructure like that, and I'm sure there's people kind of developing that sort of thing.
Yeah, there's a lot of people out there developing platforms and solutions for Internet of Things.
There's all the appliance manufacturers.
Yes, my main concern with appliance manufacturers is that they tend to get bored. So, you know.
A lot of them want to lock you into their particular ecosystem. So
the
you can have the Samsung world, or you can have, you can't mix
so
them.
you've got your Samsung thing, or you've got your Sony thing, or you've got your, you know, you've got your home hub from somebody that won't talk to anybody else's stuff. So instead of having a home hub, you've actually got 5 of them. You've got your Microsoft one, your Sony one, your Samsung one, your
Apple one.
Your Apple one.
We don't understand.
But they do make nice kit.
But it's shinier.
So that's a problem that we've got to get over. I don't think that we're going to necessarily solve that, but our picture says instead of having a hub in your house, we'll get everything talking HTTP in the cloud somewhere, and then we can just connect it up with APIs and REST and things, and so shiny and great that way.
Is there any adoption of IPv6 in this area, or is that something which is
We're not seeing any, I've got to be honest.
It's surprising that's not being used to, given the numbers.
It is surprising. I've got to be honest, the network stack in the end doesn't yet support IPv6. We'll get it at some point soon. Well,
but you're not being pushed for it, so
the thing is, because of the way that our system works anyway, it talks to our cloud, and then the connections are all unidirectional. It'll work with home NAT or carrier grade NAT anyway. So it's less of a problem than you think for our stuff, but if everything's talking to everything else, then suddenly it becomes a problem. The problem with IPv6 is it's kind of complicated to adopt.
It is.
I looked at doing it myself at home. I thought, I'm a fairly smart guy. I can do this. I've even got an IPv6 range on my static IP. 18 billion addresses.
Well, it's been built into most systems for a long time, but it is difficult to use, no doubt.
But I thought if this is going to take all weekend to implement, so just check the box somewhere.
The mobile phone networks have basically got IPv6.
Yeah.
I wouldn't say it's difficult. It's just different. Shouldn't it? You've just got to.
It's much more complicated.
They're longer addresses, but you can shorten them.
No, but I've got to make sure that my router's talking IPv6, even if I don't want to use IPv6 to talk to my router, because for some reason it decides that that's no, it's insane. Well, if you want to do it old school, then use DHCP6 and stuff. Old school.
Just thinking of this thing is kind of your Imp is Wi-Fi connected.
Yes.
There's only a couple of standards there and an awful lot of competing ones. Have you got your own proprietary standard for using the same frequency space?
It's just 802.11.
Right, okay, so you go with it and the rest of the traffic?
Yeah, it's not Zigbee or anything crazy, it's just 802.11.
Okay, it's a simple approach.
We don't support 5 gig at the moment because the chipsets we're getting out of the manufacturers don't support it, but it's on the list of things we'd like to do.
You going to be doing Bluetooth? Or?
We've looked at Bluetooth. Currently our recommendation is that you can just put the Bluetooth module on the Imp and get both. We've got some stuff on our website, some schematics and some sample code for talking Bluetooth low power and what it's called.
How are you going to drive down the cost of it? Because obviously that's the thing. And Intel have got this tiny little buttons thing now, haven't they? With, I can't remember what they call it now. But,
I can't assume what the cost of our thing is. Anyway, the thing is tiny. The thing I handed around is quite large. It's the old one. It's quite large. The new one's like 3,000. I think the new one after that is even smaller. Cost is pretty good. You have to check on our site to find what the cost is. In fact, you have to check with one of our partners who makes them for us, because I can't remember.
So are there any UK-based partners, or are they all based in America?
In the sense of being able to get hold of a kit?
Yeah.
Yeah, you can get a DigiKit or RS. Devops. Maybe. Yeah, probably that one.
Most things look like stuff.
Those things, can't remember. I get them for free, so it's not really a problem.
You didn't give us free samples, along with a pizza. You get a,
I need another one. I've blown this one out.
Coming back to IPv6, then surely the Internet of Things is going to put even more strain on the depleted IPv4 devices.
Well, yeah, to a point, but as I said, our stuff in particular will quite happily work behind NAT or carrier grade NAT. So it's
They'll get their own IP address from the DHCP7 and then that in through.
exactly.
So just any other device.
If you've got stuff talking to other stuff anywhere else on the internet, then yeah, IPv6 is going to be the right answer. But
Developing world.
explain the question.
Well, I mean, internet access in the developing world. I mean, that's a huge market. It's going to grow.
Yes.
And there just aren't that number of IPv4 addresses.
No, you're absolutely right. Which means they'll probably end up with carrier grade NAT. No, we should give them IPv6, but we probably won't. Because no one does it yet. Well, they do.
It'll have to come.
Yeah. Any more questions? Should we go and get some refreshments? Okay, thanks for coming.